these are the elements of an array in the memory. Okay, and I have declared that array in this syntax or in this format. It means that now this is a part of a 3D array. This is how you declare a 3D array. Then what is the number of elements? Number of elements, it is equal to m into n into 3. Okay, in your memory, the elements of the array are in the contiguous manner, and if you declare it in this format, then it means that these are the elements of a 3D array. And in case of 3D arrays, how the memory is organized is it's a collection of 2D arrays. This dimension is m. Okay, and this is a dimension for 2D array. You can change this. This is not fixed. Okay, means it might be possible that you can select p as third dimension and m and n to form a matrix. These two to form a matrix. Similarly, you can choose this to form a third dimension and m and p to form a matrix. So look at this picture and you will get it what I am trying to say. In a 2D array, what happens? There is a row and there is a column. Okay, and in case of 3D arrays, what happens is you are saying that it's a collection of these rows, these matrices, collection of these matrices. So let's take one example, in which this m you are taking as height, a third dimension. Okay, then this every square matrix. So every matrix is of the dimension n into p, and so this dimension will vary from. So this dimension will vary from a0, a1, so on, a m minus 1. Okay, so you can say that for this matrix, for this row and column, for this 2D array, a will always, the first dimension will always be 0. And similarly for this one, the first dimension will always be 1. For this one, the first dimension will always be 2. For this one, the first dimension will always be 3, and so on. Here, so on. The last one will have the dimension m minus 1. Okay. For every a0, how many elements are there? There will be an n into p elements. How this is organized? Either this may be organized as a row measure or it may be organized as column measure. So let's suppose it is organized as row measure. Okay, we will suppose that the first, for a0, the 2D array is row measure, and for a1 we will assume that it is column measure. Okay, I am just complicating it on purpose. Okay, all of them would be row measure. Okay, but I am just to show the example that how the memory would be organized if that was the case. I am doing it. So if for a0, this will be the 2D array, and for this 2D array, let's say it is row measure. Row measure means first row will be in the array, and then the second row will be array. Okay, so first row will be in array, means it will be 0, and then this will go from 0 to p minus 1. So all such elements will be stored, and then a0, 1, 0 to p minus 1. Okay, and so on. a0, n minus 1, 0 to p minus 1. Okay. So all these elements will be stored in your array. And then after these, the next element will start from A1. And then let's suppose for A1, for this 2D array, it is column measure. And if it is column measure, then P will vary. P will hold for all the rows. So it will become 0 to n minus 1, and then this will be 0. Then A1, 0 to n minus 1, 1, and so on. A0, A1, 0 to n minus 1, and p minus 1. Okay. So how the elements will be stored in the array in a contiguous manner? First, all these elements will be stored. After that, all these elements will be stored. Similarly, you can understand how the subsequent elements will be stored in your array. Now, for this array, I am going to declare one and show you. This array A starts from this element and it ends at this element. So let's give the appropriate dimensions so that their product is 12. So let's say 3, 2, 2. Okay, 3, 2, 2. Now let's suppose if we take these two as this is a row and this is column. Okay, as these two for a 2D array template, and then this will be third dimension. Then what is this array? What is this 3D array? 3D array is a collection of 2D arrays. So how do you describe this? So you will say that this is a, you will say that in this you have two 3 by 2 2D arrays. Okay, let's say I select these to be my dimensions for rows and column. Then how do you describe this 3D array as a collection of 2D array? You will say that this is a collection of 3 2D arrays of dimension 2 by 2. Okay, let's say if this is selected as third dimension, and how would you describe this as this 3D array as a collection of 2D array? You will say that this is a collection of two 2D arrays of dimension 3 by 2, where 3 is the number of row and 2 is the number of column. So we will take these two as forming a 2D array for me. Okay. So how it would be like? It is a collection of two 2D arrays. This is one array, one 2D array. Okay, and there is another 2D array. Okay, for this array, your last dimension will be this one will be, for every element it will be 0. For every element, the third dimension will have the value 0 for this 2D array. And in this 2D array, for every element, the third dimension will have value 1. Okay. And let's say how the indexing would be. So indexing would depend on how the individual arrays are, whether they are row measure or column measure. Okay. Let's suppose, so I will do in a way that I will take first array to be in row measure, the second one to be column measure, and then I will do the required indexing. A 0. Okay, just assume that here you have A. I will not write A because there is no such space. Okay, I will just give 3 brackets. So for A, how many elements would be there in this array? 3 into 2, 6. So 1, 2, 3, 4, 5, 6. You know the okay. Let me tell you what I am going to do. I am going to use the third dimension. Okay, in the upward because of the space constraint, and first two dimension here. Okay. So number of elements in every 2D array is 6. So for the first array, all the elements will be stored first, and so the third dimension will all be 0 for the first 6. It will always be 0. Okay, and how these elements are going to be accessed means how this memory is organized for this 2D array is row measure. So if it is row measure means what? Means first row, then second row, then third row, and so on. So you have 3 rows here. So first row 0 and number of elements is 2. So 0 and 1, then 1, then 0 and 1, then 2, then 0 and 1. So the first element is, so all of these elements are there. Okay, it means if I populate, it means what was my matrix? It means my matrix is this 1, 2, 3, 4, 5, 6. One is A0, 0. One is A0, 0, 0. And 6 is A. And 6 is A. Last one is 0. And last row means 3 rows now. 2, 1. Okay, as you can see 0, 2, 1, 0, 2, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0. Now after this matrix is stored, now this 2D array will be stored here. Okay, so what would be the index? Now what I am assuming that for this 2D array it is column matrix. It is column measure order. Okay, this is here. If it is column measure order, then number of column is 2. So this will be 0, and for every column you have 3 elements. So 0, 0, 0, and then 1, 1, 1. Okay, and in a given column, for a given column, then you have in that column the elements will go from 0, 1, 2. 0 means this dimension will go from 0, 1, 4. 0, 1, 2. And this will always be 1. 1, 1, 1, 1, 1. Okay, so that's how the indexing would be. So what would be the elements? How the elements would be in this 2D array? It's a column measure order, right? Column measure order. So 7, 8, 9, 10, 11. This is row measure order. And this 2D array will be in memory is organized for this 2D array as column measure order.